Good morning. What do we have for today? If everything is settled, I think we can start the lecture. Let me just double check that the recording is also. Yeah, it is there. So, yeah, okay. All right. Now, just to make sure before we start, I think the slide that we all shared now has only a title, which is 3.6 generalized correlation for gases. Is this exactly what you see? A like yellowish screen with only a title written. Is that what you can see? Okay, good. So that section we have already covered last lecture. I just wanted to remind you that we started this section by talking about the special equations that are used only for gases. And we said they are called correlation equation. There are three methods. All of them are called Bitzer correlation. The first one, it is Bitzer correlation, but for the compressibility factor. And that's why you can see the one written in blue. It is for the compressibility factor itself. In other words, you are going to use Z is equal to Z0 plus omega Z1. Now, how to get Z0 and Z1, you have to go to Lee-Kessler table, which is appendix E1 to E4, and you need to get the values from there, or the values of Z0 and Z1. Then I explained the second method last lecture, which was again Bitzer correlation, but for the second virial coefficient. The second virial coefficients, those are the coefficient of the virial equation of C, B and C. But when I say second, means I'm talking about B specifically. So that's why what I did here, I found or we used the B equal to B caret is equal to B naught plus omega B1. So we found B caret, and then from B caret we were able to relate it to B so that we can substitute in the equation. Now, just to emphasize on one thing, I mentioned last lecture that you can either use 1 plus B P over RT or 1 plus B over V, but both will not give the same answer. And who will guide me on which method I have to use? In the question, it's supposed to be guided. If not, then you can choose whatever method, you choose your personally, yani. But it will not give the same answer, close answers, but not the same, because you are truncating it. And if it is close to ideal gas, then the difference will be very, very small. Okay, so that is the Bitzer correlation for the second variable. Again, you will find B naught, B1, B caret, and then you will convert B caret to B, or you will substitute here directly if you don't want to convert B caret to B. Okay, so, and then the last method, it was Bitzer correlation again, but for the third variable coefficient. And when I say third variable coefficient, means I'm talking about the C. In other words, the third method here is actually the second method where you are going to correlate for B, and here you will add the C term. So that's why you can either use this format, the one that contains B caret and C caret, or you will use the one that's function volume where B and C are there. Okay, and here is the procedure of how to convert from C caret to C naught C1 to C caret, and then C caret to C, as you can see from this relationship. Now, that was all last lecture. Anyone has any question on the previous lecture so that I can proceed? Any question? Hello? Can you hear me properly? Any question? Okay, I can see Amina said no. Others? Others? Any question?
No.
Okay, great. So if this is the case, then I can proceed. Okay, with the students wrote no, some of them. All right. So up to here, I only covered special equations for gases. But let me take you back to this question. Does it really worth complicating the scenario and considering real gases every time? Now here's the question. If you notice in Chinky 111, we assumed ideal gas several times. Well, actually most of the time. Now, when the ideal gas will be valid, and here I will give you here rule of thumbs. When sometimes we can assume ideal gas, and khalas, let's go ahead, yani. Okay, so to show the reasonable approximation, I will show you this chart. This chart shows the range at which you can consider ideal gas behavior. It says here, the region that lies, based on this graph, the region that lies between 0.98 and 1.02, we can consider ideal gas approximation is reasonable. Where is that region? Is here. You can see there? It's here. If you get any value in this region, then ideal gas behavior is acceptable. How can I get this? Check your TR values, check your PR values. If it lies in this region, is accepted. Halas? So, of course, nothing to be memorized in this graph, but that graph will guide you on whether you can assume ideal gas or not. Enzene. Plus, you have the compressibility chart that you used in Chingy 111, and that was based on two theorem corresponding of state, where we considered as the same TR and PR, we will get the same Z for all simple fluid. Here, I'm just showing several fluid over there, and how this fits with respect to compressibility chart. And you can see good agreement sometimes, somehow, but there are also deviations. Like, for example, with water fits maybe properly with TR equal to 1.2 here. But maybe with TR 1.5, you get deviations there. And same thing here with TR 1.3 and very low PR. So the idea here is sometimes you can use compressibility chart if the fluid can show good fit with the presented data. So that is another thing. And the previous chart, this one, it can be either written, or it can be either given to you to test whether ideal gas assumption is valid, or I can give it to you as range. What do I mean by range? This one. Yani, when I say this region, I can express this region also by ranges. Yani, if PR is less than 0.0001, but any TR, where is this? Where is PR? Here PR. My PR should be less than 0.0001, less than this, and any TR. That is ideal. Also, for example, another example, PR less than 0.01, so PR is less than, but any TR is supposed to be greater than 0.5. And look here, TR greater than 0.5, but PR is less than 0.01. So again, we are describing this region mainly. PR is less than 0.1, which is here, and TR greater than 1. So that's the region. So I'm covering all this region through expressions. So you would either be given, or you would have this rough guidelines as range, or the chart. Okay. Again, this is only if you are planning to use ideal gas equation rather than using the real, for simplicity. If the ideal gas assumption is valid, then you can just go ahead with ideal gas. Why not? Zip. Now, based on what I explained last lecture, now I want to solve one full problem that cover everything related, or almost all equations related to gas. Previously, I mentioned well, 2 lectures ago or 3 lectures ago, I explained variable equation of state, and we mentioned that variable equation of states can be used for gases. And if I use the 2 to 3 terms, low to moderate pressures equation, or low to moderate pressure cases can be implemented. But then we explained the cubic equation of state, but we said with the cubic equation of state, keep in mind that this is used for liquid as well as for vapor. So you can find the volume of liquid or the volume of vapor. Okay. Here what I did, I just put 311. I modified it from the question, from the book to include more methods. Okay. So that we can practice several approaches. So what I have in this question, I have methane, and it's not mentioned in the question whether methane it's liquid or gas. Now, I would say the parts of the question will give me more ideas, especially at your stage, and maybe you don't have experience enough to decide whether it is gas or liquid phase at the given property, or the given temperatures, pressures, and volumes. So here, what they need, they ask for the pressure. What is the pressure generated when 1 pound mole, so I have number of mole of methane, CH4, okay, that methane is stored in a volume of 2 cubic feet. So I have the volume of methane, and the temperature was at 122 degree F. So ideally, we have methane, okay? And that methane is in a tank where the volume is 2 cubic feet. The temperature is 122 degree F, and that methane, it's 1 pound. خلاص? Now, what they need in the question, they basically need to know what is the pressure in that tank or in this container. خلاص? This is simply the idea. طبعا, because I don't know whether it's gas or liquid, now part A give me a hint. It says using ideal gas equation of state. So definitely it's a gas. But whether ideal gas behavior assumption is correct or not, now this is another story. So that's why you can see later on, part B, they ask for the Rydrick-Quang equation. Now, to draw your attention for this, because in part A they ask for the ideal gas, then part B, the Rydrick-Quang, I know from Rydrick-Quang you can get volume of liquid and volume of vapor, but you will only find volume of vapor, because from part A we got a hint that it is in the gas phase. So you don't need to test both VL and V vapor equation. But if you check or test the V liquid, you won't be able to find the roots anyhow. So that is just for your information when you face a problem like this. And then part C, we have to solve it using the generalized correlation. Okay, generalized correlation, remember, under generalized correlation, we have 3 methods. Either Bitzer correlation for the second variable, or Bitzer correlation for the third variable, or Bitzer correlation for the compressibility. So we are going to solve it here using the simplest form of variable correlation with Bitzer. Now, and this is variable equation. Variable equation, they have to mention whether it's second or third, but since they said simplest form, means definitely it is the second. Variable simplest form, which is B. Okay, but we will see that in a minute. The first question is, what are the information I will need? First of all, the volume is already given in the question. The temperature, it is in Fahrenheit, so you have to convert it to Rankine. Why you converted it to Rankine? Always keep in mind that to calculate TR, that ratio, T over TC, okay, it should be either in Rankine ratio or in Kelvin ratio, nothing else. So that's why here Fahrenheit will not be used, but it needs to be converted to Rankine. Then what I did, I brought the R value, and you will see later on that you will need it. But since the number of moles given in pound mole, okay, so we have chosen R to be in that unit, okay? And the volume also in cubic feet, so you'll choose the suitable R value based on the given units. I will need the eccentric factor, because in part B, I need the correlation, and every time we will apply correlation, we need omega. Where to get omega and TC, PC, because I need the critical properties as well, from appendix B1. Okay, so those are the information you will need. And once you get TC and PC, you can calculate TR and P will be needed, of course. Enzyme. But ideal gas behavior is just simple, very simple, because it is PV equal to RT or NRT. Number of mole you have it, volume you have it, pressure is unknown, and temperature you have it. So it's just direct substitution. I don't want to waste time here covering Cheng 111 once again. So you will substitute and you will find the pressure, and the pressure you will get it as 212.4 atm. You will notice when I solve problems today, I will not wait for you to give me an answer, because it will really take time. I'm sure you can make the calculation yourself. You just double check it. I will emphasize more on the approach and the procedures, because that will help you a lot to solve problems. That's regarding the ideal gas equation of state values. Now, with the experimental values, they found that the pressure is 185 atm. Now, you can see there is a difference. Okay, it is deviated from ideal gas behavior. The real case is not actually ideal gas, but based on the ideal gas, we are getting like maybe acceptable result. That is with regards ideal gas. Now, with the second equation, that is Cheng 211 using Rydrick-Quang. الحين with using Rydrick-Quang, you know that you will use the generalized correlation. Make sure that always that the equation sheet that I already uploaded in my Blackboard is with you you have the table that shows the cubic equation of states, the generalized cubic equation of states, and for Redrich-Quant, any other, or not only Redrich-Quant, any other cubic equation of state, you will need to find A and B, and you will get epsilon, sigma. So this is what I did here. I found A, that's function of T. It was just direct substitution, okay, for the TC, PC, and the values here. I got the value of B for you. Now it's only a matter of substituting in this equation. So the R value, I already wrote it for you there above. Temperature, it is 581.67. The volume itself is, now here is very important. That volume here, it is a specific volume. You can see the unit of B, it's 0.4781 cubic feet per pound mole. In other words, here, that's B in per mole. So V is supposed to be specific volume. Of course, in this question, you are lucky that the number of mole is 1 pound mole. And it will not matter whether you put 2 cubic feet or 2 cubic feet per pound mole. But it will be a big mistake if the number of mole was not 1, then it will highly affect your final answer. So that V is a specific volume. I will repeat. Okay, so, and then here you have the A, which is already constant value here based on the value we got. And the specific volume is 2, and plus B, so it's just direct substitution and you get the volume. So you can see here from the final answer, we are being closer to the experimental result. So considering the cubic equation of state, we are closer to the experimental value. So Redrich-Quant give quite a good approximation over the ideal gas. So that is with regards to part B. Now with regard to part C, we have to use the simplest correlation. Simplest means it is second, because we have second and then third and then higher order term. So second variable equation of state, this is what we have to use. So I use only 2 terms. And then the question here, Doctor, shall I use 1 plus BP over RT or 1 plus B over V? Well, both can be, any of them can be used. But keep in mind that they will not give the same answer. Depends on your procedure. We are going to follow what you are doing. 1 plus BP over RT is equivalent to 1 plus B caret BR over TR. So you have the choice either to find B caret or B. So in either case, you will start with this. Step number 1, you will calculate B naught. And how to get B naught? It's function of TR. We already calculated TR above from TC. So I just substituted here to get P naught. And I got it minus 0.09840. And then I substituted here of TR to get B1. Knowing B naught and B1 should allow you to substitute in the B caret equation. Remember, you will need the asymptotic factor. From where you get this? From appendix B1, as I mentioned before. It has a value of 0.012. Now, khalas, it's ready. I have B caret. Now, here, look at that. Here, B caret is there. Now, I have B caret. To get B, you need the critical property PC, which is from table or appendix B1. R value, we have it as 0.7302. TC, I have it as 343.1. Rankin, again from appendix B1. Then I can get B. If you got B, you can substitute in this formula, which is 1 plus BP over RT, or from B caret directly, you can substitute here. Okay? But it will be dangerous there. Look, if you substitute it here, then you will have P that is unknown on the right side and P that is unknown here, because Z is equal to what? Here, Z is equal to PV over RT. Okay? You can still play with the equation to get P, no problem, but I would, here, whether it was here or here, you will find P on both sides. But upon rearrangement, you will have P only in one place. Okay, this is one option. Another option, to avoid having P on both sides, you can just write it as this. PV over RT is equal to 1 plus P over V. If you did it like that, then P will be on one side only. But keep in mind, this answer will be different from the answer you will get from here. But both are accepted because both are related to second variable equation of state. Second variable equation of state is actually the B itself. And you have made the correlation for it. And then, before I proceed with the other thing, anyone has any questions so far? Anyone has any question? Hello? Any question?
No, we're good.
Okay, good. Also, Amina said no. Others? You all fine so far? Okay, hello, Kalam. I can see so many students are okay and happy with it. So that is, as you can see, chapter 3, you just need to know which equation you have to use. The rest is just substitution. Then, last part here, I want to do Bitzer Z correlation. It is the correlation for the Z. And again, you are going to use the omega, but not for second variable, not for the third variable, but for the Z. So Z is equal to Z naught plus omega Z1. And remember, to get Z naught and Z1, you have to go to what? To Lee and Kessler correlation. Then I will say a very important message here, guys. Very important. If you have the book with you, that is going to be great. Okay, I'll give you just 1 minute to open your book. If you don't have it, later on, you can see from the recorded movie, you can go through what I will say now. There is a big difference between Bitzer Z correlation using Lee-Kessler, which is using the table what? Appendix E1 to E4, or correlating Z0 and Z1 using second variable coefficient. شنو معنات هالكلام؟ Listen. When you go to the Bitzer correlation, in 7th edition, it is page 101. If you don't have the 7th edition, I will tell you the title. The title, it's Bitzer correlation for the second variable coefficient, which was what? Which was actually this, part C. But here, you will notice that later on in the next page, page 102, there are equations that relates Z with B1. Where are those equations? Maybe better to show you those equations. Let me clarify this furthermore. Yeah. Page 102, you can see there is a relation between Z0 and B0 and Z1 and B1. Then, Victoria, what does it mean? Before I go to part D, I will explain this. Okay? Here in part C, there is Z0 and Z1, but we are going to find Z0 and Z1 from Lee-Kessler. Lee-Kessler means what? Appendix E1 to E4. Okay? But if it is, if they said use Bitzer correlation, but for the second variable and for B, okay, Z0 and Z1 are related to B0 and B1. And I don't want you to mix up here. There is a relationship between Z0 and B0, Z1 and B1 in your book, and that was given in equation 363 and 364. Well, actually 364, mainly 364. That shows the relationship between Z0 and B0, Z1 and B1. And then, Doctora, where we are going to use those? We are going to use those only if they ask you to relate Z0 and B0, or if they ask you to use the second variable, the correlation using the second variable. That is not correlation for Z, because I am relating Z with B0. I'm not relating Z with Z0 and Z1. خلاص? So that's why here, whenever they say Bitzer correlation for the Z using Lee-Kessler, means you have to use Lee-Kessler table. And you have to go to the table, which is appendix E1 to E4, and substitute there. And see, I hope this is clear before I proceed. I don't want to proceed if that point specifically is not clear. Clear? The point is clear? Okay, good. I can see yes here. Hello. So, the idea here basically is that you need to get Z0 and Z1. But we have a problem. Oh, what's the problem, Doctora? Let me show you. Al-Hin, if you remember last lecture, I mentioned that appendix E1 and E4, to get the Z0 and Z1, I need to have TR and PR, because Z0 and Z1 are function of TR and PR. TR, I have no problem with it, because I have T and I have TC. But the problem mainly here is what? Is with the PR. How can I get PR if I don't have P? Remember, in the question, they were asking for P. Okay? The question itself, they were asking for P. So if I do have PR, then why do I have to use Bitzer correlation? I mean, in the question, they need P. Okay, so I have a problem here. I cannot get Z0 and Z1. So how to get, what is the trick behind this? Okay, the trick is, Since you don't have any pressure and you want to start and you want to get Z0 and Z1, the only solution here is to start with initial guess. شنو يعني initial guess? Just guess the pressure because it's gas, huh? So to get the pressure, I will start with an initial guess, and that initial guess is the pressure of ideal gas behavior. ليش ideal gas? Because this is the only pressure that I can just start with, and I know it's supposed to be close to the case. Maybe not very close if the deviation is high, but at least it's an initial guess that I can start with, and it should lead to knowing the final answer. So I will start with initial guess by saying P is equal to RT over V, which is part A of this question. So I just brought this answer from part A. Now that I have the pressure, this is not the actual pressure, but this is my initial guess of the pressure. So from this pressure, what will I do? I will calculate PR. How? Using P critical. So P over P critical here, you can see those two values, P and P critical. So I will divide to get PR. And of course I have TR. So I have PR, and then at this PR and at this TR, I should go to the appendix, find Z0 and Z1. And then later on, I will talk about the details of how can you calculate Z0 and Z1 using interpolation. But I want you to know the mechanism now. You have to get Z0 and Z1 from appendix E1 to E4. And then, if you got Z0 and Z1, then we should be ready to get Z, because Z is equal to Z0 plus omega Z1. Omega, we got it at 0.012 for methane from appendix B1. So in this case, it's just direct substitution. So what I did, I just substituted directly to get Z. But in the question, they don't want Z, they want P. And of course, Z is equal to PV over RT. صحيح? So in this case, if I have the Z value, I can find the P. Actually, P is Z RT over V. يعني P is Z into RT over P is actually P ideal gas. In other words, every time I will multiply my Z by the ideal gas pressure, which is here, then I will get the corrected P. So in this case, I found the corrected P. But the question again, is this the P is the correct answer? Now that was based on my initial guess when the pressure is 212. But when the pressure is 212.4, my calculation led me or took me to another pressure, which is 190.91. But this might not be true again, because that is just corrected. So I will repeat the same procedure again. I will take this pressure divided by PC. I will repeat that, from this P, I will calculate a new PR. طبعا TR will not change because T and TC are constant, given in the question. Then I will calculate a new Z0, a new Z1, and I will repeat that part. And this is what I did here. Look, from the pressure that I calculated, I got PR, new PR value. The PR value led me to, or from the PR value and TR value, it led me to find out Z0 and Z1. Then I will substitute in the Z0 plus omega Z1 to get new Z, and I will multiply it by the pressure. This will give me a new, look at that, the value close, but now it will start to be fixed. When you repeat the procedure several times, it will be fixed. Yani, I put 189.97, which is a difference of 0.03 ATM. I personally decided to stop. And when will you stop? Sometimes they mention in the question, مثلا, stop if the difference is, that's called the error. If the error is 0.03 or the resolution and the iteration is 0.03 ATM, just to stop. Or you will just decide on it. If the difference is very close or the difference is very small, خلاص, you can just stop then. So this is how you do it. We come up with the last answer, 189.97. Maybe if you repeated it 1/4 or 5th times, you will get it maybe 189.91. I would say fair enough. That is a good place to stop. Okay, so this is how you have to do it. And then I will repeat again, Z0 and Z1 iteration will be, I will show you later on how to do the interpolation itself there. Okay, in another question. So that will summarize or finish off the part related to gas. I have now to cover the liquid, and then I will discuss the tutorial. The reason why I did not start with the tutorial directly, I want to cover everything related to chapter 3, because next week you will have a break. So good opportunity for you to solve as many problems as you want during the break. If you finish all the material of chapter 3. And then before I proceed, let me just ask one more time, any question Any question, guys? Hello? Okay, Mariam, she said, from where we got Z is equal to 0.8988. Okay, I will repeat here. Z, according to the definition of Z, Z is equal to PV over RT. Then, so to get the Z value, Z is Z is equal to PV over RT. So to get the Z, I have to, oh, sorry. You are asking for Z specifically. To get the Z, it is Z is equal to Z naught plus omega. Z is equal to Z naught plus omega Z1. This is the bizarre correlation for the compressibility. So Z naught I have it, Z1 I have it, omega is 0.012, then I can get Z. As easy as this. Okay, Mariam, clear? Okay, according to the feedback I got, everything is clear. Okay, that's good. Mariam also clear for her. It's wonderful. Khalas, I'm done with the gas side. Now I will cover the equation. Section 3.7 is only the equations that are related to liquid only liquid. Remember, previously, I will remind you, previously we talked about liquid. At the beginning of this chapter, we covered beta and Latin K expression. That can be used for liquid. Also, we covered cubic equation of state, and we said we can use it for liquid. Here, the generalized correlation for liquid, I will start with other methods, but I want to remind you here that yes, we can use a cubic equation of state, and it gives high accuracy, as we mentioned before. And this information maybe you haven't seen before. Leakisler correlation can still be used for liquid. يعني using Z is equal to Z naught plus omega Z1, that can also be used for liquid. Okay, it's supposed to be non or slightly polar fluid, because that we already mentioned before that it's used for non or slightly polar fluid. The word fluid means it can be liquid or it can be vapor. But the new information here is that since you know that the definition of Z is deviation from ideal gas, يعني even liquid, if you got, for example, Z is equal to 0.1, I know it's far away from 1, but it is deviation from ideal gas. يعني Z can be used also for liquid, and I can use this equation for liquid as well. Today what we are going to cover, I will cover other methods. Here I have one method that can be used if you have saturated liquid mainly. If you have saturated liquid, then there is a famous equation, and this equation is called Racket equation. Okay, highlighter. So this is Racket equation, and Racket equation is just one equation, simple, one line. Once you have got the V critical from appendix B1, Z critical from appendix B1, you can see here that equation is only function of T. TR is T over TC. يعني once I give you the temperature, you can find the volume. And this will take me back to Gibbs phase rule. If you check saturated liquid, the number of properties needed to fully define the system is only 1. And this is one evidence here. Once I give you the temperature, you can find the volume directly. And I told you before, how is another story. How to find the properties, another story. This would answer one of the questions. How to get the volume, if it is using Racket equation, once I give you the temperature, you can get the volume. Another way, you can use the PV diagram. With the PV diagram, at the given temperature, you can find the volume. But here we are talking about the equations that are needed, not the graphs. So the one famous equation here is Racket. I will give you the temperature, and you will substitute to get the volume. Okay. And is there another form of this equation? Yes. This second equation here is another alternative, and you can use the first equation or the second equation. Both should give the same answer. But that equation is written in terms of Z. يعني you will substitute in Z critical, which you get it from table B1, appendix B1, and again it's function of T only, but this will take you to calculate Z. طبعا once you calculate the Z, خلاص you have no problem, because Z is equal to PV over RT. You will substitute to find the volume. That's simple. One equation, substitute, and that's it. This is only if it is saturated liquid, not any liquid, not compressed. It is saturated liquid, and on the saturation line. Okay, so that is regarding the first method in that section. Second method, it is called Lederson, Greencorn, and Huygens equation. I know it is lengthy name. Those are the people who invent or who give us this chart. but you can either use that name for the three authors, or you can just call it density. Was it? Oh, I think the yellow is just a bad color to use here. Okay, so that it's either used the name of the author, or you can just call it density correlation. Density correlation chart. It is chart that it make correlation for the density. How is this? If you remember the compressibility chart, it was a plot of Z versus PR. Compressibility chart, you remember from Chenge 111? And there you have TR and VR on the chart. This looks somehow similar, but the x-axis shows the PR, the y-axis shows rho R. And if this is the case, you can just simply find, you can find the rho R value. How? By giving the PR, for example, the intersection with the TR will give you what? Rho R value. And then rho R value, if TR was given, if TR was given, PR was given, means T and P were originally given, right? يعني the unknown that is needed is volume. And then this chart will give me rho R, not the volume. Okay, let me show you how to get the volume from there. And they are, according to the definition, reduced property. Any reduced property means the property over the critical property. يعني TR is T over TC, PR is P over PC. يعني rho R is also rho over rho C. And then back to Chenge 111. Rho itself is the inverse of specific volume. So that is rho R. I will divide it by rho C. Rho C, density at critical, it's 1 over VC. يعني in other words, rho R is VC over V. Okay, and those V are the specific volume. Okay, per mass. So here is what I have. So in other words, once I get VC from appendix B1, okay, I can calculate V from the rho R that I will get from the chart. So again, the procedures are as follows. At the intersection between PR and TR, you will get rho R. Then using rho R value, you will substitute in the equation given here in the rectangle box. Okay, from this rho R that you will get from the appendix, from the charts, and this VC from the appendix, you will get the specific volume. That would be the third variables to complete the P-T-V relationship. That is how to use this chart. Insane. On this chart, there are two methods for it. Two methods. One method is the method I mentioned. Another method will give maybe more accurate result, and I will tell you this. Method number one, if no experimental data were given, then the rho R value that you will get from the chart, you will have to substitute it in. Okay, no, I didn't mean to be here. Yeah, okay. All right. So if no experimental data are given, as we said, all you need is the rho R from the chart, and then you will get the volume from this relationship. And then more accurate result is if experimental point is needed. In the question, you will notice sometimes that they do have experimental point, يعني one extra data given to you. And this extra data is experimental point or value that will help you to get more accurate result. And then how to apply this method? You can just consider this equation. Now I will tell you just where this equation came from, but I will solve one full problem that clarifies this idea. Here, what it says just relate the point that is given and the point that you need to calculate. Okay, rho R1 over rho R2 means you will need to calculate. One value will be given to you, the other one you will need to calculate. Okay, and this will be related to their volumes. طبعا rho R1 means what? Means VC. Okay, just write it here. Rho R1 means VC over V1, and rho R2 is VC over V2. So this will give me the left-hand side, V2 over V1. This is how it is. How can we apply it? I will just show you in this example. So what I will do now, I will just explain one full example that clarifies the liquid. Liquid part is very easy. The special equation for liquid part are only two. One is using bracket equation, the other one using the chart. But under using the chart, there are two methods. I will show them here. Plus, remember, there is a third equation, which is Lee-Kessler. Why Lee-Kessler, Doctora? Because I mentioned at the beginning that leaky slurs still can be used, which will give also a good approximation if you have none or slightly polar fluid. So that's why if I want to summarize the liquid special equation, well, the special equation for liquid are 2, plus the third equation, which is leaky slur. خلاص? Okay. So I will solve one full problem that summarize all this. Here we have been given ammonia. Okay. Can I just ask one thing? I want to make sure today that I don't leave you until everything related to chapter 3 is covered. So will you mind if I take 10 more minutes from you today? Yani until 10. That's okay. Okay. Anyone has any objection? Sure. Okay, I can see sure from Musa. Okay. Okay, hello. Thank you very much. I highly appreciate this because I'm sure it will help you a lot in the break to solve more problems if I covered everything related to chapter 3. Zain. So here in this example, again, this is example 313. I just modified it to cover as many methods as possible so ideas becomes clear for you. We have ammonia, which is NH3, and that ammonia at temperature of 310 Kelvin, they want us to estimate the molar volume. And again, they have to mention, is this volume of liquid or volume of vapor? Because at your stage, maybe you don't know that ammonia at 3110 has a liquid phase. So here they mention that estimate the molar volume of saturated liquid. Wow, that's clear. The word saturated liquid is just a quick hint, very easy, that I need to use the Racket equation. So let me just talk about part 1 first. So with part 1, it's simply using Racket equation, and all I need is to get the critical properties. Where to get the critical properties? From Appendix B1. When you go to Appendix B1, you will find the V critical ready for you. You will find Z critical ready for you for ammonia specifically. You will find the T critical ready for you. Then it's a matter of substitution. Where students normally make mistakes here, when they put the power over power. And I know here you have to check that you don't make mistake when you substitute. خلاص. The idea here is just bringing the critical properties from the table, TC, PC, VC, ZC, and TR, and just one click substitution, you will get the final answer. طبعا the saturated value, I got it as 28.33 centimeter cube per mole. The experimental value was 29.14. يعني good enough, or maybe accepted approximation, but that is based on the requirements in part 1. Easy. What do we have in part 2? In part 2, they still need me to calculate or to estimate the volume, but they give me the pressure. I will remind you again, if it is saturated condition based on Gibbs phase rule, I only need to know one property, and that's why they give me that it is the temperature, Tsat. At Tsat, we found the Vsat accordingly. But here in part 2, they changed the question by saying, no, it is not at saturated. Estimate the volume, but when the pressure is 100 bar. Yani at the same temperature is same, 310 Kelvin, but the pressure here is 10 bar. So it's no longer saturated. But how to get this? Using a 3 method. They said generalized correlation, density correlation chart for liquid, which is the chart that I showed in the previous slide. Then using the chart, but I give you here experimental value. They said experimental value of 29.14 centimeter per mole for saturated. And if it is saturated, the experimental value gives 29.14. I don't have saturated here, but this is additional information given so that it helped me getting more accurate result. And last thing, I will solve it using leaky slur correlation. خلاص? زين. Let's see. I brought the chart for you, and I want to solve part A only. What is part A? Generalized density correlation. And what that method says, that there is, you have to get rho r from the chart and then use this formula. Okay, what is that formula? It relates the critical V with the V, and then I need to find the V because this is the unknown. Simple as this. طبعا from the question, I do have the temperature and I do have the pressure. And from Appendix B1, I have the critical temperature and the critical pressure. In this case, PC and PR and TR are ready for me, which is TC over T and PC over P. Wonderful. So what I did, I came to the chart here. I know the readings are not, and you won't be able to get TR as 0.764. Look, I have here 0.7, I have here 0.8. Yani, you can just use, like what you did in Chinggit Trouble 1 is the compressibility chart. Try to get 0.76 as good as possible. And I don't know if I can get it right because I'm using the pen. And then at PR is 0.887, you just check here the x-axis, PR is 0.887, around 0.9. So I cannot get it maybe very, very accurate, but yeah, maybe 0.9 would be here, let's say. Okay. And then the intersection should give me rho r. I personally use my own resources and my own program, and I go through R as 2.38. For you, maybe you can read it as 2.4. Maybe you might not be able to get it as 2.38 or maybe 2.35. Fair enough. As we did in Chinky Triple One, as long as you put the point correctly here. Okay. And I'm sorry if I'm not doing it right. I'm just trying to illustrate the idea. So as long as you showed in the assessment that you made the intersection correctly, you read the value, that's fair enough for me. Then this rho r, you have to substitute in VC over V. طبعا VC we got it from appendix B1, so it's just a matter of one simple calculation, substitute of the critical volume, and you will get the value. Look here, I got it 30.45, okay, from the chart. The experimental value was 28.6. Now, I will use part B to compare. If a data was given, am I going to get closer result to the experimental value or not? And mostly, yes, but we will see now. So this is regarding using the chart. الحين, I want to give you information to use method 2 of the density correlation. Let's see. Here I said, again using the chart, but now you have to know that when it is saturated at this temperature, you get a volume Vsat is equal to 29.14. When is this? When the temperature was 310 Kelvin. So these are given information here in this question, but they ask for the volume, of course not saturated. This is the volume of the pressure is equal to 100 bar, and the temperature is 3110 as given in the question. But they give us an information or some information here related to a point. Which point is it? It is the saturation condition. And then how to do this? Be careful with me. What I did, I used the chart. Oh, maybe I have to go back and show you. I used the chart at this Vsat and at this T. Look there. I have at this temperature. They said the experimental value of 29.14 at this temperature. What is that temperature? It is 310. Okay. So in this case, I can get how to get this. How they get this value, when you go to the chart, if the temperature is 310, I can get TR, and TR is already 0.764. So that will give me, those two information will give me one rho R. I can call it rho R1. And Victor, how can I get rho R1? I will show you. This is T is equal to 310. At this 310, what is the corresponding rho R? When you go to the chart here, okay, TR, when the temperature is 310, TR is 0.76. Now, when you go vertically here, you can see there is a dashed line. It is called saturated liquid. يعني the intersection here between TR of 0.7, I have to go to TR 0.7. So TR 0.7 is this. The intersection between TR 0.7 and the saturated curve or dashed line will give you a rho R value. So my reading for the rho R value was 2.34. And I call this one rho R1. So what I did, at 29.14, I get rho R value from the chart. How is this? By going to the dashed line, the intersection of TR with the dashed line give me the value. Okay, this is what I did just right now. So in this case, what I have rho R1, and I also have rho R2 that I got it from part B. Why I got it from part B? Because rho R2 at a pressure equal to 100 bar and temperature equal to 310. In other words, at PR is equal to 0.887 and TR is equal to 0.764. I already found it in part B. If in the question they did not give you the part A, they give you part B directly, fine. but you have to find it again because you need rho R2. You need 2 rho R's. Now this method says that rho R1 over rho R2 is equal to V2 over V1. This is how it is. Okay, and to substitute in this equation, you need to have rho R1, rho R2, and V1 to get V2. Okay, and to do this, okay, no, I think that is V1 over V2. I'm wrong. V1 over V2. So my unknown is V2. Okay, so at rho R1, it depends. The unknown, it depends on what you have. So what I did here, I called rho R1 for 2.34 here. Rho R2, I got, I can get rho R2 from the table. So in this case, you will just need to substitute. Rho R1 over rho R2. Okay, again, that's not. Anyhow, you don't have to memorize the equations, but it is this. Okay, so you need to substitute in the formula. And how to substitute in the formula? Let me just show you once again. Rho R1, we got it from the chart as 2.34. Rho R2, it is 2.38. How is this? At the PR and TR, since P and T are given. So in this case, all we have to do is just to substitute. How to substitute? Okay. How to substitute? I got rho R1 as 2.34. I got rho R2 as 2.38. Now what I need to do, I need to get rho, at this 2.34, how much is the volume, which is V1. And at 2.38, we already get the volume, sorry, at 2.34, the volume, rho R1, is given in the question as 29.14. But V2 is the one that I want to calculate, as I mentioned, so then you will find V2 according to this relationship. طبعا, if you get V2, خلاص, you have no problem, because this is what they need in the question. Before I proceed to part C, is this method clear? Because that method is slightly more complicated than the first method. With part A, it was just you use the chart once and you will substitute in the V is equal to VC over rho R, or rho R is equal to VC over V. Is the second method clear, guys? Second method is clear? Anyone has doubt? I need an answer. Hello? No doubts. Okay, I mean, no doubt. The others no. Okay, that's wonderful. So if this is the case, we were able to we will be able to find V2 directly from this relationship. Now let me show you the final answer. I got the final answer as where's the final answer? Oh, here. Sorry. The final answer, I got it as 30.45. Oh, that is part A. What is the final answer for that? Yeah, sorry. The final answer here is get it as 28.65. You can see? 28.65. Now, comparing part A, that's part A. Comparing part A with part B, my value here in part B is closer to the experimental value compared to part A, simply because I am having one extra data or information or experimental value that helped me to get more accurate result. Okay. So that's regarding part B. الحين, last part here is Leakesler correlation. What is Leakesler correlation? It was exactly what we did with the gas. Z is equal to Z0 plus omega Z1. Here, where I want to show you how to use the table from your book, which is Appendix E1 to Appendix E4. I explained this last lecture, and I asked you to go to Appendix F to practice the interpolation. Here, I will show you in details how I did this. I need, generally speaking, I need Z is equal to Z0 plus omega Z1. So I need to get Z0 and I need to get Z1. So what I did, first of all, I will show you Cheng-Triple-1 method. Okay, Cheng-Triple-1 method for the interpolation, you have to go at the Z0 and Z1, sorry, at the TR and PR values. So here it's 0.764, 0.887. Let me just write them down here. 0.764. 0.887. That is TR and that is PR. So we have to go and find out where is this. Around 0.764, it is somehow here. 0.764. Okay? 0.887, it is in between 0.8 and 0.1. So you can see there, to do interpolation, what I did is this. I got the values here. I know that the value is supposed to be somehow here, exactly there, the intersection between 0.887 and 0.764 here. But to do interpolation, I need to know what is the value that is here and what is the value that is here to do the interpolation. And this is what I did. What I did for you, I made interpolation, which is Chengi triple one approach, interpolation between 0.133, 0.1307, and 0.75, 0.78, while 0.764 is my value. And in other words, before you tend to do like this, y0, y1, y2, and you will need to find the y in the middle, where x1, x2, and x, which is 0.764 here. So, and this using the equation of Chengi triple one, I was able to get this y. But this will only show me the value here, 0.1323. I have to repeat the same procedure once again on the right side to get 0.1647. Then you will have to do interpolation between 0.13 and 0.16 to get the Z0, which is really a lengthy process because you will do interpolation to get 0.132, another interpolation to get 0.164, a third interpolation to get the one in the middle. And you have to repeat the 3 steps again with Z1 because you need Z0 and Z1. And this is what I did here. I did one interpolation, second interpolation, and the third interpolation to get Z1. Now that I have Z0 and Z1, what I did, I just substituted Z is equal to Z0 plus omega Z1, and I got the answer for you. It's 0.131. Then to get the volume, it is Z into RT over P. So my Z is 0.131, RT over P. Okay. Done, it is done, but it is lengthy, as I said. So referring to the appendix, those are the details. Anyone went through the details and had a concern, or you did not go through the details? I don't know really what's your case. Did you check whether you can make interpolation using the method written in your book? Yes? Did you do that? Did you go to the appendix? Okay, Amina, you have an issue or you are okay? So it's only Amina who answered now? Okay, Muhammad said he tried. Amina, she's okay. All right. And then I'm just going to explain that for those who did not try or they have doubt. You can either use Chengi triple one method, the one I just explained, it's called single linear interpolation. If you don't remember Chengi triple one method, here they explain the method, but in a different way. Okay? How in a different way? They are giving example. If you have, for example, T and H, where T1 is given, T2 is given, and T is given that's needed there. In other words, this is my X1, this is my X2, and X is the one that is given. And you need to calculate from Y1 and Y2 here, you need to calculate the Y, which is H. Then you have to substitute in this equation. What is that equation? It relates X and Y through that formula. Best, I would say, if it is single linear interpolation, you can just simply use Chengi triple one method. Fine. But the problem is, the problem is what to do if you will need to do like this. This is called double interpolation. Why double? Because you will need to find interpolation like twice and then find the third one. So double interpolation can be done again in a single step, one single step. And I will show you that. Look here. In Chengi triple one, when you want to apply interpolation, you will only need to calculate the value here. This is linear interpolation, which is single linear interpolation. Value here. But now here, as we said, it's either that you need to calculate the one above, the one below, and then the one in the middle, or the one on the left, the one on the right, and then the one in the middle. But instead of doing all this, it's here only one single equation. What is that single equation? Is that, you remember the box I did here? I will give it symbols. Okay? I will consider here that the symbols are as follows. Y1, Y2 for the TR values, X1, X2 for the PR values, and the readings of the Z are written as a matrix here. M11, they give it just other names. M11, M12, M21, M22 for the values around, and the one in the middle is just M. Khalas, if you understand this I will apply it here. Again, I will repeat. Here, it is M11, M12, M21, M22. The one I want to calculate is M, which is in the middle, in the center. Knowing that the value is here, the that we have plus the interpolated value here would give me, or just direct substitution will give me the final answer for M. Whether M is Z0 or Z1, because you will repeat it. That one here, you don't need to do 3 interpolation for Z0 and 3 interpolation for Z1, yani 6 interpolation using Ching-1 method. Here you will only use it twice. This equation, you will use it twice. One to calculate M1, Z0, the other to calculate Z1. And that's it. This ends the chapter. It is 10 o'clock now. I'm done with the chapter. I got a question from Ali 317, and I got also a tutorial sheet. So what I did here, to make things easy and new, I uploaded the tutorial sheet. Frankly speaking, you really don't need. Let me just share with you the tutorial. You don't need me in the tutorial sheet because every single idea in the tutorial sheet, I already explained it in a class. So I uploaded the tutorial sheet. You can play with it in the break. But where is it? Let me see if I have it here. Okay. I think it just takes time to share the sheet with you. Where is it? Okay, can you all see the sheet? Hello? Can you see the sheet? Okay, you can see it. That's good. So this is the sheet. I put several problems, but just I will scan it with you. 332 is just asking you to solve finding Z and V, but using different methods. And I did exactly similar problem before, using truncated variable, using Ricky-Quine, using solved Ricky-Quine, Ping-Robinson, and here, yeah, that's it. So it's just using the cubic equation of state plus Bitzer correlation. And I did exactly the same problem before. With the 341, we need to estimate the volume. Some questions, sometimes they ask you to estimate the volume, but they don't tell you what is the method. This is not going to be the case here in Ching 211. We will always define the method for a simple reason. We don't want to get more than one solution in the assessment. Okay, but if the method hasn't been specified, then you have to choose the appropriate method. And which one will guide you on which appropriate method? When I was explaining each method, I was explaining the suitability of the method. This is suitable for gas, this is suitable for liquid, and so on. But I also suggest that you can go through, where is it? I will just see if I have it here. There is one nice problem. It was 364 in the 7th edition. 364 give a summary on which equations can be used, if it is gas, if it is liquid, and there was interesting chart that is drawn in problem 364. Okay, so for 341, the method hasn't been specified. You can choose your own method, but the model answer, Smith, he chose his own method and he solved. So you can just follow the same or use the same method there. But as I said, we will always specify the method, or we will ask you to choose the method that we know that you have no option other than this, to avoid having more than one model answer. For 353, it was clear that they give you the density and they ask you to estimate the density, and it's liquid, so definitely you will use the density correlation method. Last thing here, 350, they ask for the molar volume of liquid. Molar volume of liquid. And in other words, you will need to use cubic equation of state for liquid only, or you can use other methods, as I said, if it's left open, because you do have methods that are only used for liquid. Then that is just the problems. I will be available to answer your questions during the break, but there will not be any lecture. Okay, if you have any question, you can just send it on the on Microsoft Teams, or you can just email me. I have no problem. I have a promise that I need to solve 317 for who? For Ali. If you want to leave, that's fine. You can leave. Ali, are you around? I don't know if he's around. Ali, are you around? Ali? Okay, maybe he's not. He's not today. In this case, I will ask you, do you want me to solve 317? Or you can check it later, and if you have any question, I can answer it. But that 317 was just based on Ali's request. So that's why I was thinking to solve it. Anyone has any concern?
دكتورة بس أنا كنت بسأل بخصوص الحضور.
بخصوص؟
الحضور attendance.
انزين خليني أكمل بس الكونتنت وبعدين I will answer your question. Is that okay? انزين.
Yeah.
Any question? Can we just stop the lecture with that? انزين. I will just mention something regarding the 317 because Ali has a question and maybe he will see the recording. With the 317, maybe it seems confusing because there was a mistake. I think there was a mistake in the model answer. Just for everybody, 317, with the model answer, he swapped V1, V2. It's actually supposed to be the other way around for V1 and V2. And the pressure that was given in the model answer, it was not, I think it was written P2, so it's supposed to be P1. So it's only swapping. If you just know this information, I don't think 317 will be difficult for you to understand. It was just a mistake in the question, in the model answer of Smith. That's it, يعني. انزين. I'm back to you. Any question apart from the question related to the attendance? Any question? Hello? Any question? Can you just write in the post whether you have a question or not? Ra'id? No. Okay, none has a question. So Noor, Ra'id, Arwa, Aida, you have no question. That's okay. That's good. Yeah. Regarding the attendance, what is your question about the attendance? Hello.
Do we have to attend? Do you have to attend the lecture?
Okay. Now let me clarify this precisely. Officially, I do take the attendance. And will there be marks on the attendance? Still not clear. Frankly speaking, the college are going to decide on how we are going to assess you. To be in the safe side, I'm taking record of the attendance because if they lift it open for me, I will consider the attendance as a criteria because that is maybe important. But I also appreciate that maybe you might have an issue in one day. Now, tracking whether you are going through the recorded or not, this is also another story. So I don't want to put myself with the attendance, but I know that if you missed lectures, especially that I explain the lecture and I mention, I give hints, I give ideas on how to deal with the problem. So from my experience, attending is not only important, but very, very, very important. Okay? So that is my point of view. But what will happen later, this is still not clear. I'm still waiting, or we as instructors, we're all waiting for further details about how we are going to assess you. I have to be honest here and clear with you. Okay? I hope this answers your question. Yeah?
So,
hello? Yes? Okay. Actually, I have a meeting at 10, but I prefer to finish all the material with you so that you have no issue. Okay, in this case, I would say have a lovely weekend, try to relax, but at the same time, solve problems to practice and you feel that you understand the material. Thank you very much. Bye-bye. نعم؟
بيتغير تقديم الأسايمنت وقته.
بيتغير تقديم الأسايمنت. I would highly suggest that you send it. And if there is a decision about the fact that because you are going to send it electronically, so you won't need to see me so that you can upload it. You can upload it following the time that we agreed on. Okay?
Okay.
All right. Okay. Bye-bye.